In this lesson, we will work on few problems which involves the inequalities of triangles theorems. So let's look at the first problem. We have been given a triangle and we have been told that BC is greater than AB and BD is the bisector of the angle ABC. And we are required to prove angle BDC, which is this angle, is greater than the angle BDA, which is this angle. Let's try to prove this. We have been given BC is greater than BA or AB, which means the angle opposite to the longer side will be larger based on our theorem 1. So the angle opposite to the longer side is BAC is greater than the angle opposite to the smaller side, which is BCA. So that is in 2. We also know that angle ABD is equal to angle DBC because BD is the bisector. It will bisect the angle into two equal halves. So angle ABD is equal to angle DBC. We can also say angle BDC is equal to angle ABD plus angle BAD, which is this angle. So that's exactly what we have written here. Angle BDC is equal to angle BAD plus angle ABD because this is the exterior angle, and exterior angle of a triangle is equal to the sum of the interior opposite angles. Similarly, we can say angle BDA is equal to angle DBC plus angle BCD because this is the exterior angle for this triangle. So we have written that as well. So now subtract 4 and 5. Now when we subtract 4 and 5, on the left hand side we will have angle BDC minus BDA, and on the right hand side we will have angle BAD plus angle ABD minus angle DBC minus angle BCD. But angle ABD and DBC are equal from 3. So those two things cancel out and we will have angle BAD minus angle BCD, which is nothing but angle BAC minus BCA, because in the case of angle BCD, if I extend D to A, the angle still remains the same, and similarly in the case of angle BAD, if I extend the angle D to C, so it will become angle BAC and still it will remain the same. But we also know that angle BAC minus angle BCA is greater than 0 from 1, because we have been told angle BAC is greater than angle BCA. So if you bring the right hand side to left hand side, it will become angle BAC minus angle BCA greater than 0, which means angle BDC minus BDA is also greater than 0 because the right hand side is greater than 0, the left hand side also is greater than 0. So angle BDC minus angle BDA greater than 0. Taking this to the right hand side, you will have angle BDC is greater than angle BDA. So this is exactly what we had to prove. Now let us work on another problem. The problem states that if the two sides of a triangle measure 3 centimeters and 8 centimeters, find all possible measurements for the third side. And we are only looking at positive integers for measurement. So first let us call the measurement of the third side as x. We know from the inequalities of triangle theorem 3 that the sum of two sides of a triangle is always greater than the third side. So x should be less than 3 plus 8. 3 and 8 are two sides of the triangle. So the third side x should be less than the sum of these two sides. So x is less than 3 plus 8, which means x is less than 11. So we have one relation. Similarly, x plus 3 should be greater than 8 because x is one side, 3 is another side. So the sum of these two sides should be greater than the third side. So x plus 3 greater than 8. So which means x is greater than 5 because you take 3 on the right hand side, it will become x greater than 8 minus 3, which is x greater than 5. Similarly, x plus 8, which is again sum of two sides, is greater than the third side 3. So this will result in x greater than minus 5. But we know that a side cannot be negative. So it is as good as saying x is greater than 0. So that is your third relationship. So this is your second and this is your third. So now let's consider this number line and try to identify where x lies. So from the first relationship we have x less than 11. So x can take any values between 1 and 10. But from the second relation we have x is greater than 5. So x should be between 6 and 10. The third relation is x greater than 0, but we already have another relationship which says x is greater than 5. So this thing will not apply. So only thing is x is greater than 5 and x is less than 11. So the possible values of x are 6, 7, 8, 9 and 10. So the third side of this triangle can have either the measurements of 6 centimeters, 7 centimeters, 8 centimeters, 9 centimeters or 10 centimeters. So this is how you solve this problem.